Hello. In today's lecture, I'm going to solve more problems on free fall. Okay. Before I start solving problems on free fall, I want to remind you that for a free fall in one dimension, the acceleration is constant and it's equal to minus gravity. Okay. So if we take the positive x-axis to be upward, acceleration will always be downward and it will be equal minus gravity. Okay, because the acceleration is constant, then these four rules can apply. These four rules can apply. Okay, so let's do together one problem we did together in our live session today. So there is a girl that pushed a ball from O, where the ball reached height A, and then it went back to the floor. Okay, and the given was that VO equal 15 meters per second, and the height at which the girl is standing, it's 1.5 meters. So this was given. Before I start by solving this type of questions, I put on my drawing all the information I know from free fall. In red, I've put everything. From the origin, okay, I know that XO is 0. Because we always take the origin to be the place where you push the ball or you leave the ball. In case you don't give it a push, you just drop it. So always take position there is 0. VO equal 15 meters per second, it's given. The ball will go up, up, up until it reaches point A. So VA is 0. The velocity at A is 0. It will stop. What is the position at point A? It is the maximum position, because the ball cannot go higher than that. So at A, the ball stops. The velocity will be 0. The x will be x maximum with respect to O. Actually, with respect to anything. Then what do I know about point B? I know that it is on the floor, down, down, down. So it's in the negative direction of the x-axis. So XLB equal minus 1.5 meters. And VB equal V maximum, because when the ball starting going down, it will speed up, speed up, speed up until it stops at, until it reaches point B. After that, after hitting the floor, it would stop. But just before it hit it, the V is V maximum, okay? And I know also that the acceleration equal minus 10. This is the most important thing. And this is why we use these four equations, okay? We use these four equations because the acceleration is constant. Now let's start. Determine the time needed for the ball to reach the maximum height. So we are going from O to A, okay? We are going from O to A. What do I know about, what do I know from O to A? Do I know VO, VA, acceleration, delta XOA, delta TOA? I know VO, it's 15. I know VA, it's 0. I know acceleration minus 10. I don't know the X of A. And the unknown is delta OA. So I look at my four equations and I find that the third equation is the equation I must use. So VA is 0 equal VO 15. Acceleration is minus 10 delta T. I solve it, I get delta T equal 1.5 seconds. Okay, part B, determine the height, the maximum height reached by the ball relative to the ground. Okay, so I want it relative to the ground. So first I know that this is from here to here is the ground. And then I have to add to it this distance from O to A, okay? So from here to here is what? This is H. From here to here is what? It's delta X O to A, okay? So it's actually this guy over here. It's delta X O to A. So I go back to my box here. I know VO, I know VA, I know acceleration, I even know now delta T. So what is delta XOA? I use the fourth equation. You can use the second equation, the first equation, all of them will give you the same answer. Delta XOA is 11.25. You add to it the 1.5 height from the ground, and then you get H maximum. Okay. Beautiful drawings. Part C. After time t equal 2 seconds, is the ball going upward or downward? Okay. Here I have to use common sense. I know that for the ball to reach A, it takes 1.5 seconds, and that's the maximum. So after time 2 seconds, where will the ball be? Will it be above OA? It will be going upward, or it will be below OA? Below A, it will be going downward. Definitely, it should be going downward. Okay. So it should be going downward. So 2 seconds is greater than 1.5 seconds, implies going downward. Let's call this point C, because they're asking me questions about point C. Calculate its position. So I need to get delta X O C. So what do I know from O to C? I know that VO is given 15 meters per second. I don't know VC. I know that the acceleration is minus 10. I don't know delta XOC. This is my question. And I know delta TOC, which is 2. So which equation I will use? I have VO, I have acceleration, I need delta T, and I need I know delta T and I need delta X. The only equation I can use is equation number 1, because it contains all these values I have. So delta XOC is V initial delta T plus half A delta T square. VO is 15, delta T is 2. Half A, it means minus 5, because 10 over 2 is 5. Delta T is 2 squared. So I will get delta XOC is 10 meters. Delta X from O to C is 10 meters. Okay. Last part. Calculate the time needed for the ball to reach the ground. Calculate the time needed for the ball to reach the ground. So what is the initial position of the ball? Oh, what's the final position of the ball? B. So I want to go from O to B, from O to B. What information do I have? Do I have VO? Yes. Do I have VB? No. Do I have acceleration? Yes. Do I have delta XOB? Yes. It's minus 1.5. And do I have delta T from O to B? It's actually asking for it. The equation I can use here is also the first equation. Delta XOB equal V0 delta T minus 5 delta T square. Here, this is minus 5, is 10 over 2. Okay. So take it here, 5 delta T square, and get the other side as well, minus 15 delta T minus, yes, delta XOB is minus 1.5. So minus 1.5 equal to 0. This is actually a quadratic equation. This is a quadratic equation where you use the calculator. Okay, just Google it, how to use calculators to solve a quadratic equation. And it will give you 2 answers. One is positive, one is negative. You will reject the negative because time can never be negative. Time is always positive. So we get delta T equal 3.09 seconds, and it's the accepted answer. Okay, so with this, I end the lecture of today. If you have any questions about this lesson, you still have time to ask. Thursday for the live session, I will also be working on a free fall and probably some horizontal motion before I move on next week with the new lesson. So if you have any question, just send me an email exactly which problem you found difficulty in, and we can do it together during the live session. Okay, that's it for today, and bye-bye.